Welcome to the Goldilocks story. This is an example of behavior-focused, test-driven design. So what are the objectives or tests for this brief session? Well, I'd like you to be able to understand one way to approach test-driven design. And secondly, see an example of a remote studio that we use for training. Now, I've got a suggested but not required prerequisite. There's a video on the flow of behavior-driven development and test-driven design. Hi, I'm Ken Pugh. I'm the Chief Consultant with Ken Pugh, Inc. I'm the author of 7 books: Lean, Agile, Acceptance, Test-Driven Development, Better Software Through Collaboration, Prefactoring, which is about extreme abstraction, extreme separation, and extreme readability, and that won the 2006 Jolt Award. And I'm also the co-creator of SAFE, Agile Software Engineering. I've got a couple of principles. The first is no code goes in till the test goes on. We're not going to start an implementation until we have a test that tells us that implementation is done. And the second is the power of 3. And in particular in design, as Jerry Weinberg once said, if you cannot come up with 3 solutions to a problem, you don't understand the problem. So, here's our application. What we want to do is check the temperature of porridge before eating. Now, obviously Goldilocks did this manually, but there's got to be an app for that. And so what is our app going to do? Well, we've got Goldilocks on one side and the porridge on the other side. And the app is going to tell Goldilocks when the porridge is just right. So let's look at the scenario for this application. And the scenario is going to be developed by the triad: the developer, the tester, and the customer. The 3 perspectives who are responsible for the quality of the product. So let's look at the overall scenario. Given a bowl of porridge, when the porridge temperature is measured, then the appropriate indicator is displayed. So here's the application scenario with a little more detail. Here's the cold scenario. Given the cold limit is 70 degrees, and that's in Fahrenheit, we'll come back to centigrade later on. When the porridge is 69 degrees, then we should display blue. The hot scenario. Given the hot limit is 90 degrees, when the porridge is 91 degrees, then display red. And finally, the just right scenario. Given our cold limit is 70 degrees, our hot limit is 90 degrees, when the porridge is 80 degrees, then the display is green. There's our set of application scenarios. Now we can just rewrite this slightly, and for a display, an indicator for a temperature, we'll talk about the domain terms, the cold limit and the hot limit of 70 and 90. And chances are we might want to change the colors a little bit. So we have too cold blue, too hot red, and just right green. Now when we measure the temperature of the porridge, the display should show a particular color. For example, 69 should show blue, 70 should show green. Notice those are breakpoints around that cold limit, and 90 should show green, and 91 should show red. Now we have a full-scale application scenario. Next, we have the scenario from the Goldilocks to the porridge, but now we've got to decide what components we need in order to pass that external test. Well, maybe we'll have a display, a processing, and a measure component. Here's where you probably will come up with 3 different solutions and determine which one is the best. But we're going to drive this with some tests. So, here's one way to implement this. We have our overall scenario for displaying the indicator for temperature. We've got our 3 parts: display, an indicator determination, and a measure. And of course, we have Goldilocks and porridge on the outside. So the question is, should display call indicator, which calls measure. Should measure call indicator that calls the display? Maybe we should have another component that coordinates all these. Multiple ways to design something. So we're going to pick one of them, work through a few tests, and see if they're working out. So you can look at it as here's the input, there's a process, and there is an output. The measure is going to pass the temperature to the indicator determinator, and it's going to read a configuration file for those hot and cold limits, and then pass the state to the display. And then the state is going to read the configuration file to determine what colors to display, and then display them to Goldilocks. Now, once we have the overall flow, now we can break it into behavior for the individual components. Determine the indicator state for temperature. And we have our indicator determination. We've got our configuration file, which it's going to read. And now, let's look at what one of the scenarios or tests would be for this. We've got an input and an output. So here is the scenario. Given our cold limits, our cold limit and hot limit of 70 and 90, when the temperature is a particular temperature, then the indicator should be a state. So here's some examples. Our 69 and 70 should return our too cold or just right, and our 90 and 91 should return just right and too hot. Now we have a scenario, i.e. a test for just this component. We might code this test in a unit testing framework, and that might look something like this. We're going to make sure the correct indicator's state is returned for cold. We'll set our configuration value so the cold limit is 70. We'll create an indicator processor and pass it 69, and we'll test that the state it returned is too cold. Now we have a test for our component. We might look at it and go, looks like there is a little too much coupling with configuration. Chances are not, but in a lot of cases this might be. In which case then we're going to alter our indicator processor, come up with a slightly different test given our cold limit, and we're going to pass the cold limit to the indicator processor. So it no longer has a dependency on the configuration. And then the rest of the test will look the same. We'll pass it 69, and we'll check to see that it actually returned too cold. So our test can help show us coupling, which is a design issue. So let's look at other components. Well, our indicator determination gets a value from our measure, and we might want to have a measure test double if we have a more complex method for communication rather than just one method calling another. And the indicator determinator talks to a display, so we're going to have a display test double. And now we're going to have a slightly different test that makes sure that the measure communicates correctly with the indicator and the indicator communicates correctly with the display. And this would be if they're more complex than simple method calls. So let's look at our test here. So we have a coupling back with configuration because we figured out maybe that's not too bad of a coupling. We're going to create a new measure test double and a display test double. And then we'll set the temperature of the measure test double to 69. We'll pass the measure test double and display test double to the indicator processor. And then we'll ask the display test double what state was passed to you. And once again, it should be too cold. So let's look at a couple of the other components. Here's our display. We're going to display a color for a particular indicator state. So it's going to read the configuration file to determine what color. And we'll have Goldilocks look at the display and say, is that the right color? Now we have a test we'll probably be doing manually because we need to have a human being say, is that the right shade of green? So here's our scenario for the display. Given our indicator colors are too cold, too hot, and just right, that should be blue, red, and green. When the display receives an indicator state, it should display a particular color. So too cold should display blue, too hot, red, and just right, green. Now we have our test for the display. We've got one last component, that measure component. Now it's going to measure the temperature, and it's going to have some sort of a probe that it will stick into the porridge so that we can measure what the temperature of the porridge is. Let's write a test for the measure component. We're going to measure the temperature. Given a bowl of porridge, when the temperature is a particular temperature, then the measurement is a particular measure. And maybe the way that the measurement is made is slightly different than what we actually want to pass to our indicator. So here's our temperature with its measure. 70.0, we want to pass 70. If it happens to be 69.5, we'll pass 70, but we'll also round down if we're below 0.5, so we'll pass a 69. Now this test, actually we need a physical bowl of porridge, and we'll need to heat the porridge up and cool it back down and make sure that it actually passes the test. So, in our previous indicator determination, we had a measure test double. But now if we really want to test our measure more automatically, well, our measurement device, which is in the porridge, is going to communicate somehow with our measure component, but we'd like to test it more and more automatically, and we don't want to have to get a bowl of porridge out and keep heating it up and cooling it down. So we'll probably create a measurement test double. That will be able to allow us to test our communication as well as any processing inside of measure. Temperature. I told you we'd come back to this. The cold limit, 7 degrees Fahrenheit. Well, most of the world uses centigrade, so we should be able to have a cold limit of 21 degrees centigrade. Now this suggests that temperature should be a domain term. And we create a class that represents that domain term, pass it the string value 70F or 21C. It'll make sure it's a legal value, and convert it to some internal representation. And of course, we'll need a greater than and a less than method as well. Perhaps we also want to do this in Kelvin, just in case Goldilocks wants really a cold bowl of porridge. So next, how much time and whose responsibility is to measure that time? What I mean by that is, when we put our probe into the porridge, it doesn't So, how much time and whose responsibility is to measure that time? What I mean by that is when we put the probe into the porridge, it's going to take a little bit of time to reach the actual temperature. Should we manually wait for X seconds? Should we have a timer that waits for X seconds? Or should we monitor the change in the temperature? Well, 3 solutions to the problem of time. Let's just look at a couple of scenarios for this. Display the measurement in progress. Given the measurement is started, when X seconds pass, then the indicator is shown. Or perhaps we display the changing indicator. Given our measurement device is in the porridge, as the temperature is still changing, we're going to display something that indicates the measurement is in progress. Maybe a gray display. And I'll leave it up to you to come up with more detailed scenarios / tests for the time responsibility. Well, to summarize, what we've shown is one way to approach test-driven design. And you also saw an example of a remote studio that I use for training. how to experience TDD and BDD and ATDD as well. Behavior-focused test-driven development and design. It's a 5 half-day course taught remotely using breakout sessions for pairs. And pairs can either be 2 developers or a developer and a tester. And we cover how to design and how to test. And lean, agile, acceptance test-driven development and behavior-driven development. Better software through collaboration. That's the triad, the developer, the tester, and the customer perspective. And we want all 3 in this course. And in this course, unlike some others, we use the team's real stories for the exercises, what they are currently working on, to put the concepts into real life. We have 2 half days for all the teams with some breakout sessions for each team, and a half day follow-up for each team that we make sure that they've gotten all of the stories and the scenarios so they completely understand the requirements. If you're interested in that, contact me on LinkedIn, Ken Pugh, or email me, ken@kenpugh.com. Thanks for listening, and be safe.